Expand the general expression to sum of product form. So we are given this expression, and this expression is what we call a sum of products. So this kind of an expression is called sum of products. We normally have two types. We have sum of products, and we also have what we call product of sums. Whereby when we have A plus B, maybe not, plus A, and this addition we multiply with another addition like A plus C. So when we have variables that have been added being multiplied, we get product of sums, which is abbreviated as POS. And when we have multiplicated or when we have multiplied and variables that have been added, we get sum of product. So this is a sum of product. And when we are taught to expand, we have what we call standard either POS or standard SOP. Sum of product is SOP. So in this case now, when we have to make the expressions standard, we mean that every term, for example in these three terms, every term should contain all the variables in the domain. All the variables in the domain. In the domain, we mean that this expression, the whole of it, when we look at the distinct variables, we will find that it is made up of A, another distinct variable is B. Don't say we have B and not B or C and not C. We look at the variables alone. So the distinct variables are A, B, C, D. So we have A, we have B, we have C, and we have D. So every term in these three in this expression should contain the four variables. If we have to consider this, we should see A, B, C, and D inside it. We should also see A, B, C, D here, and lastly we have to see A, B, C, D in the other one. So for example, for this one, when we look at it, we are missing a D. Here we are missing a C and a D, and here we are missing A. So we are going to expand it, that is making it standard expression. So this is how we approach it. I've said this is a sum of product, which is SOP expression. To make a standard SOP, that is now the expansion. To make standard SOP, what we do, for every expression whereby we have a missing variable, we have to multiply that expression. We multiply that expression with missing variable and its complement. Missing variable and its complement. That is sum of missing variable and its complement. We multiply with missing. We multiply with sum of missing variable, and its complement. We shall see how we do it. So you have to be very keen. This question was weighted for 5 marks, and it may seem easy, but it has several steps. So for example, every group I will take every group and make it standard. by making sure every variable is there. So I will take the first one. The first one is A, B, C, not C, that is. And in this variable, we are missing a D. So what we do, we multiply with missing variable, which is D, added to its complement. That is what we have said. You multiply with the sum of missing variable and its complement. So when you do this, you will find that the result will give us an extra term. And that is now what we are going to achieve. So when you use distributive law, if you remember, we multiply this variable with whatever is inside the bracket. We shall have A, B, not C, and then D. We add A, B, not C, and not D. So in that case now, we have expanded this term and we have got two variables whereby the two have all the variables in the domain. So this one has A, B, C, D, and this one contains A, B, C, D. So we have to keep that one because it will be part of our final answer. Let's go to the middle term. The middle term is missing our variable C and D. So we have not A and B. We have not A and we have B. It is missing C and D. So in the first step, we will multiply with one of the variable which is missing, and next we multiply with the other. So in this case now we have A and B. We will multiply with the C plus C naught plus not C. So we have to expand this first, then next we multiply with the D. So here we shall get not A, B, C. We add not A, B, not C. So now our new expression has got ABC, but it is not having D. So we expand further these two to contain D. So we shall have not A, B, C. We multiply with D and not D. And next we shall have not A, B, not C. We multiply with D and not D. So when we expand our first expression, we shall have not A, B, C, D. We add not A, B, C, and not D. We add not A, B, not C, then D. We add these to not A, B, not C, and not D. So as we can see, when you multiply with a variable and its complement, the variables multiply. So in this case, we were missing two variables, which is C and D. So it means we will get the variables will multiply by 2. Every variable will bring up two other variables. That is why we are getting 4 of them. So our middle variable not A and B, we have expanded it now to contain all the 4. So we have to keep this one because we'll use it in our final answer. So the last one is B, C, D, and this one is missing variable A. So we have B, C, D. So we take our variable B, C, D. We multiply with A. We multiply this with A and not A. So in this case, we shall have B, C, D, A plus B, C, D, not A. So as you can see now, our two expressions have all the variables A, B, C, D. So now we will take all what we have gotten for the expansion of every term and we join it as one expression. So our first one was this. So you copy this, then you add the next, then you again you add for the last one. So this is what we'll get. We take this, we add to the other one. So this is we have the previous one is A, B, not C, then D. We add the next one, which is A, B, not C, and D, and not D. Then this one we add this. So we have not A, B, C, D. We add not A, B, C, not D. We add not A, B, not C, D. We add the last one here, not A, B, not C, not D. And the last one we have what we have gotten here. We add B, C, D, A plus B, C, D, not A. So now this expression now forms our expanded expression, which is, in this case, we call this a standard SOP expression. This is a standard SOP expression, which is sum of products, because we are adding multiplied variables. So that is how you approach such a question. So the question could be framed like we make it a standard sum of product form.